Hello everyone, I'm Young First. Welcome to my channel. This is a series about self-mock technical interview. Today we will solve the daily problem in LeetCode together. So let's start. Open the algorithm page of LeetCode and find the daily problem. It's a medium. The difficulty of the problem is medium, so I think we should solve this within 20 minutes. So let's start. Let's read the description together. If Flatten a multi-level doubly linked list, you are given a doubly linked list which in addition to the next and the previous pointers, it could have a child pointers which may or may not point to a separate double linked list. Those children list may have one or more children of their own, and so on, to produce a multi-level data structure as shown as level here. Flatten the list so that all the nodes appear in a single level doubly linked list. I think the solution is very straightforward. We just need to recursively flatten that because, for example, here we don't need to do anything, and for this we need to flatten all the sub list, and then concact the last one. So it's a natural recurse solution, and the number of nodes is 1000. So let's start. I think the recurse solution is the time complexity of recursive solution is big O(n), because we just need to recurse iterate every node just once. There is a we need a help recurse function, and the node is the head. The arguments are head, and we need to return. What do we need to return? We need to got the last node, and I think the first node. So it's a pair of node, just first and last. Node of the list and the last node of the list. In fact, I think we don't need to return the first node because the head is always the first node. So remove that. And here we need to concact the children. Children. We need to flat the children first. This is an S1 of children, and we need to use the variable to record the next pointer, and we need to make the next is the children, and the children is none, and the last of children is here, and we need to get that. No, it's the last one, so we need to make that and return this. So, and the recurse head, and the space complexity is O2 because the recurse stack depth is n at the most. So, and here is a non-pointer situation we need to deal with. If head is none, so we need to return none, and children. And if next, so if next is none, we need to return children. And if children is none, if children is none, we just the next. It's a little complexity. I need to make sure we are right. So here is the 1, and the children is none. The children is none. So we return that, and the children is still none. So we get that. And the children is not none, and we we put that here and got the got the 10 and 10 tens and next return cursor and here if we got this return recursively and hand is not now and children is now. We return this. We need to here if it's less else we should return head. So let's run the code. Valid. Here, let's run the exam in our brain again. Okay, because we forget update the prev variable, so there is something wrong. So we need to update that. How do we need to do that? So let's do that recursively too. So let's run it. So I think it's right now. Let's run all the examples. So let's try to submit that. Yes, we did that. Congratulations on me. So here I will do some summation. First, for those kind of problem like linked list or single forward list, we can use the recursive solution to do that. Also, if you meet some tree problem, you can use a recursive solution too. And here you need to be careful when you deal with linked list problem, because the pointer is very difficult to update, and you need to be careful enough to avoid the better memory access. And in this problem, we in fact don't need the prov variable. We can deal with the single linked list with the same solution with this function, and because it's a doubly linked list, so we have to use more statements to update the prov variables. And I think this problem also have some space complexity is O1 solution. It's literate instead of recursive solution, but I think we don't need to do that in a real interview, because the space complexity is not as important as the time, and usually it's easier to write the recursive solution, and with the recursive version, you can rewrite it into a literate solution. It's kind of easy, so I want to do that in my video. So I think that's all my episode today. So see you tomorrow. Bye bye.